In a statistical study, sampling methods refer to how we select members from the population to be in the study. If we wish to arrive at some conclusion about the population by using the information contained in the sample from that population, then our sample must be a random one. If our sample isn't randomly selected, it will probably be biased in some way, and the data may not be representative of that population. Several techniques have been developed to enable us to test the hypothesis that that a sample is random. The technique to be presented here is based on the number of runs which a sample exhibits. Today our topic is one sample runs test. The objectives of this test is to test the number of runs in a sequence, to test the number of runs which may be considered random, to test for difference in dispersion. Assumptions of this test: normally distributed. The data from the sample are arranged in the order in which they were selected. Each letter, number, or event can be classified into one or two mutually exclusive categories. Runs test is a non-parametric test that is used to determine if sequence of data values occurs at random. A run is defined as a succession of identical symbols which are followed and preceded by different symbols or by no symbols at all. For example, consider these variables or symbols. We can group these letters or scores into runs by underlining and numbering each succession of identical symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 runs. In the second situation, there are 1 and 2. 2 runs. In the third situation, there are 1, 2, 3, 4, 5, 6. So there are 6 runs. The last example, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 runs. The total number of runs in a sample of any given size gives an indication of whether or not the sample is random. Let n1 the number of elements of one kind and n2 the number of elements of the other kind. And the capital letter N, the total number of observed events, which is n1 plus n2. n1 might be the number of heads and n2 the number of tails. Or n1 might be the number of pluses and n2 the number of minuses. If very few, erase muna natin. Okay, if very few runs occur, a time trend or some bunching due to lack of independence is suggested. Ang example niyan is yung Example number 2. If a great many runs occur, systematic short-period cyclical fluctuations seem to be influencing the scores. Ang example yan is ito. Let's take these two examples. For example, suppose a coin were tossed 10 times and the following sequence of heads and tails was observed. Here in the first example, too many runs are observed. In this case, with R is equals to 10, R means runs. When the capital letter N is also equals to 10. On the other hand, only 2 runs occurred in 10 tosses. This would seem to be too few for a fair coin. Kaya, ang events are lacking of independence. Ang tinutukoy kasi natin dito is the sequence of events in a sample selected random. Hindi balancing ng events na dapat kung 5 ang heads, dapat 5 din yung T or tails para fair, hindi siya ganyan. Ibig sabihin nito, ang example number 1 at 2, reasonable to reject the hypothesis that the coin is fair. So neither of the two sequences seems to be a random series of heads and tails. In the third and fourth example, we can say that these samples are selected randomly. Dahil makikita naman natin na hindi natin ma-predict or hindi natin alam kung ano ang takbo ng mga variables na ito or symbols. Hindi natin alam kung ano ang kasunod na lalabas. Kaya these two, a sample is a random. These two gives us the information that we failed to reject the null hypothesis that the sequence is random. Have you noticed in our analysis here, which is based on the order of events, gives us the information which is not indicated with the frequency of the events. In the first and second example, wherein there are 5 tails and 5 heads occurred, if the scores or if the scores were analyzed according to their frequencies, for example, by use of the x-squared test or binomial test, we would have no reason to suspect the fairness of the coin. Kasi goodness of fit type ang tinutukoy doon. Diba? So, it is only a runs test focusing on the order of the events, which reveals the striking lack of randomness of the scores and thus the possible lack of fairness in the coin. Okay, method or procedure in conducting a runs test. Hindi ko na babasahin ito, i-screenshot na lang. Sasabay ko ito Bibigkasin ko na lang ito kasabay ng ating example para makuha o maintindihan ang procedure steps in conducting a runs test. Basta ang importante sa test na ito, dapat may N1 and N2 tayo. N1 and N2 events in the sequence in which they occurred and determine the value of R, the number of runs. I-screenshot nyo na lang para proceed na tayo sa ating example. But before that, may small samples tayo and large samples. For small samples, if both N1 and N2 are equal to or less than 20, then refer tayo sa table F. Table F gives the critical values of R under the null hypothesis for alpha is equals to 0.05. These are critical values from the sampling distribution of R or runs under the null hypothesis. Two tables are given, F1 and F2. F1 simply gives the values of R which are so small that the probability associated with their occurrence under null hypothesis is P is equals to 0.025. Ito yung sa lower tail ng normal bell curve. At saka yung table F2 naman gives values of R which are so large that the probability associated with their occurrence under the null hypothesis is P is equals to 0.025. Ito naman yung sa upper tail ng normal bell curve. Any observed value of R which is equal to or less than the value na pinapakita sa table 1 or is equal to or larger than the value na pinapakita sa table F2 is in the rejection region of rejection for alpha is equals to 0.05. So yan ang tinutukoy ng two-tailed test. And for a one-tailed test naman, if a one-tailed test is called for if the direction of the deviation from randomness is predicted in advance. Kumbaga, alam natin, like sa example ng kanina ng heads and tails, the situation 1 and 2, diba, na pre-predict natin, alam natin kung ano ang takbo or arrangement ng events. So, kaya gagamitin natin ang one-tailed test. Then, only one of the two tables need to be examined. Either sa small or large na value. Kumbaga, or either sa lower tail or sa upper tail. If the prediction is that too few runs will be observed, so ang gagamitin natin yung table F1 gives the critical values of R which is yung the lower tail. If the observed R under such a one-tailed test is equal to or smaller than that shown in table F1, ang null hypothesis natin may be rejected at alpha is equal to 0.025. If the prediction is that too many runs will be observed, ang table F2 gives the critical values of R which are significant at the 0.025 level. Ito yung sa upper tail. Ito yung table F1 natin for lower tail and F2 for upper tail. For large samples naman, if either N1 or N2 is larger than 20, the table F cannot be used. For such large samples, a good approximation to the sampling distribution of R is the normal distribution with mean at saka standard deviation. Therefore, when either N1 or N2 is larger than 20, our null hypothesis may be tested by the value of z. Since the value of z, which are yielded by the formula 4.7, under the null hypothesis are approximately normally distributed with zero mean and unit variance. The significance of any observed value of z computed from this formula may be determined by reference to the normal curve table, yung table ng z-test. That is, tawagin nating table A gives the one-tailed probabilities associated with the occurrence under null hypothesis of values as extreme as an observed z. One-tailed test lang yung table natin dito. Itong presentation na ito is for the small samples. Reject natin yung null hypothesis natin kung ang ating R is greater than the rejection region 2, kumbaga yung upper tail, and kung less than naman siya sa lower tail. If the observed value of R falls between the critical values, we accept the null hypothesis. If the observed value of R is equal to or more extreme than one of the critical values, we reject HO. Dito, in between, accept natin yung HO. Rejection region dito. For our example, for small samples, a machine is adjusted to dispense acrylic thinner into a container. Would you say that the amount of paint thinner in liters being dispensed by this machine varies randomly? If the contents of the next 15 containers are measured and found to be as follows. Use a 0.05 level of significance. Ito yung ating data ng 15 containers. The amount of paint thinner in liters. So, ito talaga yung arrangement niya na 3.6 ang una, then pangalawa 3.9, then 4.1, and so on. For our solution, number 1 na procedure, step natin gagawin, state the hypothesis and identity of the claim. So, our null hypothesis, the sequence is random. Our alternative hypothesis, the sequence is not random. Ang pangalawang step naman, since ang ating data is numerical, hahanapin natin yung median niya. Sa paghahanap ng median, diba, i-arrange natin yung mga numbers into ascending. Yan, ascending. So, 3.4 na una hanggang pataas. Then, compare each data value with the median and classify it as above or below the median. So, hanapin nyo natin yung median. So, ngayon ating median is 3.9. Balik tayo doon sa ating original na arrangement ng ating data. So, ang below the median, let natin na ang symbol niya is minus. And above the median, ang symbol niya is plus. Ayan. I-discard natin any value that is equal to the median. So, hindi nakasali ang mga 3.9. Ngayon, let's count the number of runs. One, 2, 3, 4, 5, 6, 7, and 8. So, there are 8 runs. At bilangin din natin ang kung ilan ang minus at saka plus. 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 minus na symbols. Tsaka yung plus is 1, 2, 3, 4, 5, 6. So, 6 ang plus. Let n1, the number of minus, is equals to 7. And n2, the number of plus, equals to 6. And our runs is equals to 8. Ang ating fourth step is find the critical value. Since our example is for small samples, refer tayo sa table F. So, ang rejection region natin dito is dito sa upper tail and lower tail. So, dapat ang ating R is nandito sa in between. Diyan sa loob. Ito naman yung rejection region 2 at rejection region 1. Ngayon, pumunta tayo sa table para malaman natin kung ano ang value ng rejection region 1 at saka rejection region 2. Sa F1, rejection region 1. Our N2 is 6. So, dito yung 6. At saka our N1 is 7. Ito yung 7. So, ang value natin is 3 ito. So, 3. So, upper tail naman, ang value natin sa N2 is 6. Ito yung 6. At ito yung 7 sa N1. So, ito siya. 12 ang kanyang value. So, alam na natin na ang ating N1 is, ating rejection region 1 is 3 at ang ating rejection region 2 is 12. So, dito dapat ang R is dapat ang rejection region and 12. So, dapat hindi mag in between si R. Ating value of R. So, note that ang value ng ating R is 8. So, ibig sabihin, the amount of paint thinner dispensed by this machine varies randomly. So, we failed to reject our null hypothesis. So, our null hypothesis is accepted. For our example number 2, this example is for the large samples. The writer was interested in ascertaining whether the arrangement of men and women in the queue in front of the box office of a motion picture theater was a random arrangement. The data were obtained by simply tallying by sex of each of the succession of 50 persons as they approach the box office. And this is our data. For our solution, number 1, state the hypothesis and identify and identity of the claim. So our HO is the order of males and females in the queue was random. Our alternative hypothesis, the order of males and females was not random. And step 2, find the number of runs, determine the N1 and N2. So, let N1, the number of males, 30. And N2, the number of females, is 20. Runs are indicated by underlining. So we have number of runs, R is equals to 35. And the significance level is alpha is equals to 0.05. Step 4, find the critical value. Since our alternative hypothesis does not predict the direction of the deviation from randomness, a two-tailed region of rejection is used. It consists of all values of z as computed from the formula 4.7, which are so extreme that the probability associated with their occurrence under the null hypothesis is equal to or less than the alpha is equals to 0.05. Thus, the region of rejection includes all values of z equal to or more extreme than positive negative 1.96. So this is the value of our z. This is our table A. The table of probabilities associated with the values as extreme as observed values of z in the normal distribution. The body of the table gives one-tailed probabilities under HO of z. The left-hand marginal column gives various values of z to one decimal place. The top row gives various value to the second decimal place. The value of our z is 2.9. Here we have 2.9 and 0.08. Nag-intersect sila dito sa 0.0014. The probability is twice the p given in the table because a two-tailed test is called for. Inasmuch as the probability associated with the observed occurrence
P is equals to 0.0028 is less than the level of significance alpha is equals to 0.05. So our decision is to reject the null hypothesis in favor of the alternative hypothesis. We conclude that in the queue the order of males and females was not random. Randomness is a vital for computer security, making possible secure encryption that allows people to communicate secretly even even if an adversary sees all coded messages. Most general-purpose statistical software programs support a runs test. Both data plot code and R code can be used to generate the analysis in this section. These scripts use the lew.dat data file. This is the end of our discussion for today. Thank you so much.